Welcome back, and we are going to look at injective functions. The property of injective applies to many different functions, but it is absolutely critical to inverse functions, and we'll see why. The idea of something being injective or one-to-one, so the book is going to use the word one-to-one, or the phrase one-to-one. Mathematicians more formally use injective in their language, so just so you're aware of the two bits. The idea is that if you have you have to have, if you have the same y values, right, then that means that the x values are the same, okay? So, in other words, if you do not have, if you do not have equal x's, so if the x's are different, the y's are different, okay? So, meaning that you can a function can only ever pass through a y value once. Okay, so for example, if we were to sketch these things out, you might say, you could see a function like this, right? And you might also see a function that does something like this. Okay, I have to be, yep. Both of them should pass the vertical line test, and the right one, we're going to say it does. Okay, but the idea here is if you look at a single y value, so let's say you look right here, and so you kind of look across and you say, oh, well, I have two of the same y values, right? So let's call this, I don't know, f, or let's just call this b. No, poor choice. Let's call this, we'll say this is f of a, I don't know, y value, okay? And so we see that there are two different values. There's like a1 over here, and then there's a2 on the left, right? So there's two x's corresponding to the same y, so that violates our rule, right? We have the same y value, but we have different x values, okay? Now over here, so this one on the left would be not injective, okay? Conversely, if we do the same thing over here, so I look at, value here, and there's only one y value for a single y value, there's only one x, and I can test many different cases, right? I can test this one, and I can test, okay, if I go over, I would hit here, and then I can say, okay, well, if I go here, and I hit there, so, in other words, what I could see is if I were to take a horizontal line, in addition to passing the vertical line test for a function, it would pass the horizontal line test. So if it ends up passing that horizontal line test, we would say it is an injective function. And so that's what I was just alluding to down here. Okay, so a nice way to check for this one-to-one property is if you have the graph of a function, no horizontal line should intersect the graph more than once. Okay, and then it'll have this injective property. Okay, so we want to get some practice with determining if functions are injective, both using the definition and using the horizontal line test. Okay, so what I need to look for when I have sets is same y values. Okay, so I'm looking at the y's. Okay, none of them are repeated, right? So if the function is only this, right, no y values are repeated, and I have distinct or unique, distinct y values, okay, and I'm also going to say with distinct x values, so then this is going to be injective, okay. When I look at G, right, I look at the y values, okay, then I notice that these first two have the same y value, right? Then when I do that, oh, the x's are different, right? So the condition for injective is that if you have the same x's, or the same y's, right, the x's need to be the same, but different x's. So then that implies it's not injective or one-to-one. Okay. So now graphically, with each one of these, these ones, you might not have the graph, right? You have the algebraic representation, so you might have to do a quick little sketch in your brain. So, okay, this is the reciprocal graph scaled by 4 vertically, so it more or less looks something like this, right? And so, is this going to pass a horizontal line test? So you do dun 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 dun, and this one is yes, it is going to be injective. Okay, it passes the horizontal line test. Next one, J, again, quick little sketch in your brain, shift it up one, then it's a parabola, okay, roughly like that. Does this pass the horizontal line test? Nope. We hit in 2 distinct places, okay? All right, and then now we get some functions and their graphs, just the graphs, okay? So then, again, I'm just going to do the horizontal line test. Boom, 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 boom. Yep. So I'm going to say, yes, this one is injective. And now this next one, M, yeah, it passes the horizontal. So, yes, it is injective. Okay. But if you look at vertical lines, right, it fails the vertical line test, okay? But so that means it's not a function. Okay? Be careful, okay? We could throw curveballs at you like that. All right? And so then, again, why do we care to have invertibility or to have an inverse function? We need this property of injective, okay? Or one-to-one. Again, be familiar with both bits of language, okay? So in the next video, we're going to do one more property that we'll see for inverse functions, and then we'll finally get to do them ourselves.